In this problem, we are going to determine y and z parameters. So please see here, this is how many nodes are there here, no resistance. So this V1 is same as this V1 because no element is there. But V1 and this another node, one more resistance is there. And this is V2, here no resistance is there. So this is same as V2. And here one more resistance is there. So this node is separate, this is separate, and between this node, there is a resistance, there is a resistance. So this you have to consider as new node, one more node, that is V3. So in the two put network, input side should be, input is a V1 I1, last at output side it should be V2 and I2. That's why this node should be V2. Don't write this is I1 node 1, this is node 2, this is node 3. In two port network it is fixed, output side voltage is V2, output side current is I2. So don't change it to V3 and all. So this is V2. So this node is, since there is no resistance here, this is same node as this, and here separate node is, this is V3. Now for this, you cannot convert this one to, if there is a current source like this parallel, better you have to find first Y parameter, not Z parameters, and you cannot convert this one to voltage source also because it is not having single parallel. For current source, if there is a parallel resistance, we can convert it into voltage source, but there is a, in between there is a resistance. Suppose this is not there, we can convert this one to voltage source and we can find Z parameter easily. But for this problem, first apply KCL and obtain Y parameters. So now apply KVL for KCL. For Y parameters, you have to apply Kirchhoff current law. We are applying for this one. So the current enter into the node is I1. I1 is equal to sum of these two currents. So I1 is equal to, this is 0, reference node 0, ground. So V1 minus 0 by 1, V1 minus 0 is not written, it is understood, V1 by 1, and V1 minus potential difference, V1 minus V3 by 0.5. So 0.5 means 1 by 2, so 2V1, 2V3 will come. 2V1 plus V1 is 3V1 and 2V3. So is equation number 1. Apply KCL at node 2. Node 2 is that I told no, in the two port network output is V2. So this is node. So apply KCL at node 2. I2 is equal to this current V2 by 0.5, V2 minus V3 by 1, V2 minus V3 by 1. So 0.25 means 1 by 2. So that 2 becomes numerator. So 2V2, 2V2 plus V2 is 3V2 and V3 minus V3. So this equation number 2. Now I want actually I1 and I2 in terms of V1 and V2. Here unwanted term is V3, here also unwanted term is V3. Instead of V3 I want V2, instead of V3 here I want V1. So how to eliminate this V3 means apply KCL at node 3. If you apply KCL at node 3, now you can write all the currents going away from the node. 1 current, 2 current, 3 currents. All the currents are going away from the nodes. So V3 minus V1 by 0.5. This is already current 2V1. Don't write potential difference. It is already current source 2V1. V3 minus V2 by 1. This equation V3 minus V1 left side current, down right side current. And if you simplify this, you will get V3 is equal to 1 by 3 V2. Okay, this 0.5 V1, no, 2 V1 and minus 2 V1 and plus 2 V1 will get cancelled. This will get cancelled, and you're going to get V3. This is V3 by 2. 1 by 2 means 2 V3 plus V3. 3 V3 is equal to V3 is equal to V2 will get, and V3 is equal to 3 times V2. So this is equation number 3, and you have to substitute the value of V3 as 1 by 3 V2. This value you have to substitute it as in equation number 1 and 2. You are going to get I1 is equal to 3v1 and 2v3. V3 is nothing but 2 by 3 v, that is 4 by, uh, I'll write that one equation I'll write, remaining you can do in your notes. So I1 is equal to 3v1 minus 2v3, no? V3 value is 1 by 3 v2. So it is 3v1 minus 2 by 3 v2. So two parameters we can directly tell. This is I1 is expressed in terms of v1 and v2. Y11 is 3, y12 is minus 2 by 3. So one equation is over. Similarly, apply here also. 3v2 minus v3 value is again we got 1 by 3 v2 only. 1 by 3 v2 only. So this is also v2 term. This is also v2 term. There is no v1 term. There is no v1 term. That's why you have to write 0 v1. 0 v1 plus 3 by 8 you will get. So y21 is 0. Y22 is 8 by 3. So these are the four parameters. And after that, using relation z in terms y, z in terms of y, you in the rough sheet at the end page you can try for 5 minutes, obtain using Cramer's rule. Okay, write two equations of y parameters, two equations of z parameters, and you refer my video how to obtain relation between z in terms of y. It is very easy to remember. Z11 is opposite you have to take. Z11 is y22 you have to take. 1 means 2 to 2. Z11 y22 by delta y. Okay. And Z22 means opposite. Z22 is y11 by delta z, delta y. And for Z12 you have to take minus extra, minus y12 by delta y. And similarly for y21, Z21 minus y12 by delta y. So if you remember this formulas, I'll repeat how to remember. Z11 means opposite. Y22 you have to take. And for y22 you have to take y11 and divided by delta y, that is not y delta, this is delta y. Okay, delta y is in the y matrix we have now 3 into this product of these two minus this. So it is going to get 8. The 3 will get cancelled. 8 you're going to get. So it is very easy. You can try this.